Hey everyone, just want to go over this worksheet with some of you because we're struggling a little bit with our ions. Um, it's pretty common for kids to struggle a little bit with this, but what we want to talk a little bit today is about reversing the charges. Basically, we're talking about a reverse swap and drop method. Whenever I have a reaction like 2KCl plus SRO yielding K2O plus SrCl2, and I want to figure out what the charges are, I want to go to the ions that I know what the charge is. Your group 1, group 2, group 16, group 17 elements are all going to basically have the charges that they would have based on the periodic table. And if you look at your periodic table, a group 1 element like potassium will always have a +1 charge. Okay, a group 17 element like chlorine will always have a -1 charge. And that makes sense. It's a KCl, it's a 1-to-1 ratio, meaning it's a +1 and a -1. If you do a reverse swap and drop, you would end up with the K being a +1, Cl -1. Let's look at strontium oxide, SRO. I know that oxygen is in group 16, so it's a -2. My ratio, strontium to oxygen, is 1-to-1, so that means strontium has to be a +2. Let's come back to the products now. Again, if I'm looking at potassium, I know that potassium is a +1. Oxygen is in group 16, so it's going to be a -2. And then strontium, for strontium chloride, I know that strontium is going to be based on chlorine. I know chlorine is a -1. So if I reverse the swap and drop, that means strontium is still going to be a +2. And now I'm just going to go ahead and put my charges in. And you're going to notice that they're going to be the same for the products and the reactants. Another common mistake people are making is when we come with polyatomic ions. Okay, so let's look at Na3P. Na is in group 1. I know it's a +1. So if I use the reverse swap and drop method, phosphorus then has to be -3. Okay? Calcium is in group 2. I know calcium has to be a +2. But now I have CO3. It's a 1-to-1 ratio. So because it's a 1-to-1 ratio, I should know that my charges have to cancel out. So CO3 becomes -2. You could also look on your common ion sheet on the back of your periodic table and see that CO3 is a -2. If we come here, again, we can reverse swap and drop. I know that calcium is a +2. Then phosphorus has to be calcium is a +2. And phosphorus has to be a -3. Go to this one. Again, same thing. Sodium is in group 1. It's a +1. So carbonate has to be a -2. Now, when I start writing down my ions and I have a polyatomic ion, I have to write down everything. So my ions are Na, P, Ca, and CO3. Over here, same thing, it's Ca, P, Na, and CO3. Na we said is a +1, phosphorus is a -3, calcium is a +2, and carbonate is a -2. They don't change from products to reactants. Calcium is a +2, phosphorus is a -3, sodium is a +1, and carbonate is a -2. Let's go to the last one and take a look at what we have. And again, don't worry about the coefficients when we're assigning these. Okay, but what makes this tricky is we have 3 different polyatomic ions. And remember, when we have these polyatomic ions, we don't change their formula. So if I look at this one, if I find NH4 on my common ion sheet, I know that's a +1. If I find SO4 on my common ion sheet, that's a -2. And this makes sense, as you can see, by the swap and drop, my ratio is 2 to 1. Come over here, I have aluminum and I have nitrate. The nitrate ion is -1, and if I know the nitrate ion is -1, if I do a reverse swap and drop, aluminum has to be a +3. Now again, I already know NH4, ammonium, is +1. NO3 then has to be a -1. We already said aluminum is a +3, and you can use the reverse swap and drop to get a +3 and a -2. Okay, now I'm going to go ahead and write out my ions and their charges. NH4 is an ion and it's +1. SO4 is an ion, it's -2. Aluminum is an ion, it's +3. NO3 is an ion, it's -1. Come over here, NH4 is still +1. NO3 is still -1. Aluminum is still +3. And sulfate, SO4, is -2. Just wanted to go over this with you because some people are making some errors on it, and I hope this little video helps you.